All right, so today we're going to be looking at velocity time graphs. Now, these are a challenge, okay? You got to get your head wrapped around. These are graphs of velocity. Up to now, you've mainly been looking at graphs of displacement. We've drawn a few velocity time graphs, we've worked with them, we've read them, but we haven't really sort of done a lot of calculations with them, okay? So this is going to be a bit of a new process for you. I highly recommend every time you look at a graph from now until next Friday, you take a look at the title, either here or along the axis, and ensure that you know whether it's a position time graph or a velocity time graph, because it makes a huge difference. Okay, you'll also notice a lot of similarities between this and the displacement. In fact, if I could, I'll just take a moment here, and Ryan, this could quite likely be what your brother was talking about 2 weeks ago. Okay? If you've got displacement and you use calculus to find what we call the derivative, then you get velocity, because derivative really means, in a nutshell, find the slope. Okay? So the derivative of displacement or position is velocity, and then the derivative, finding the slope of velocity, gives us acceleration. Okay? And that arrow just really means is a graph of the slope. And actually, I guess that arrow would go this way. Velocity is a graph of the slope of displacement. Acceleration, oopsie, is a graph of the slope of velocity. And when you go, the blue arrows when you're going to the right, if you're talking calculus, that's a derivative, and for some reason my eyes are dotted, that's weird. And if you're going this way in the red, the opposite, then that's called integrating. And if you go and you take, what's it called, the calculus course? Introductory to calculus, I know Mr. Mockmeyer used to teach it, Mr. Ray I think does now. The opposite of deriving is integrating. Enough said. There is actually, nobody's want to ask me what the derivative of acceleration is? Excellent question, Jordan. It's called the jerk. Jerk. You know how something's jerky? Okay? Now, I'm not talking about beef jerky, right? I'm talking about how acceleration isn't smooth. When something's jerky like that, that's called the jerk factor. There is actually a word for the derivative of jerk. I don't know. A bunch of Sheldon Coopers got it together and made up a whole bunch of words. So, no. Anyways, let's move on. Oh, I put it in the wrong spot, didn't I? Okay, so back to my original point here about velocity time graphs. Average acceleration is calculated the same way that average velocity is calculated on a position time graph. So average acceleration is similar or analogous to average velocity on a position time graph. That is by using the slope formula. The slope of a velocity time graph is the, starts with A, acceleration. Okay, so if I asked you to find the acceleration for time interval A, which is highlighted here in yellow, you would find the slope of the velocity time graph. So you would actually go rise over run. How much does it rise? It goes from 0 to 4, and it runs from 0 to 2. So my rise over run is 4 over 2. My acceleration is 2 meters per second squared. Okay? And you'll notice that that is question A, which I'm going to start right away. Okay, so I would like you to go ahead. I've given you the answer to the first one. It's 2, right? Interval A is 2. The acceleration. I want you to find the acceleration for intervals B, C. Notice that C goes from 5 to 7. D is from 7 to 8.5. E, F, and is there one more? Oh, and then answer this question. When is this object stopped? What intervals? And there is more than one answer possible. One of the possible answers, though, is G, never. Probably a very hard question. Oh, number 8, too. When is the object moving backwards? There is more than one possible answer. And when is the object slowing down? More than one possible answer. When is the object speeding up? More than one possible answer. Do you have all these questions on your page somewhere? Yeah. When is it moving at a constant speed? More than one possible answer. That is all. Okay, I'm going to give you probably about 8 minutes or so to do that. feel free to work with someone if you need to discuss it.
So question 1 is actually question 2 on the sheet.
Oh, is it?
Oh, I don't know. Just ask. Question 1 on the. Oh. Where are we? Answering?
You gave me the answer.
Question 1 is question 1. I gave you the answer.
Oh.
0 to 2, right?
I wasn't sure because you already
Okay.
gave the answer.
I'm very pleased to report that everybody got question 1 correct.
Hey.
There are times when that hasn't happened. Question number 2. You are to find the slope over that highlighted interval. Clearly it's 0. Everyone got it right. Yay. C, the correct answer is -2. Had a couple of little boo-boos there. I'm not sure what happened, but the correct answer is -2. Maybe you didn't use negative. I don't know. I can't actually see what people put. Okay? Does everyone see that it's -2? Right? So that'd be like 0 minus 4 and then 7 minus 5. 7 to 8.5, again, -2. No big surprise because it's a continuation of that straight line, isn't it? Remember, we're doing the acceleration, right? That's what we're calculating here. We're doing the acceleration from the velocity time graph. We're not just calculating slope just because slope is so much fun to calculate. E, the slope is 0. The acceleration is 0. So it looks like we've done well here. Interval F, the acceleration is 1. Had a couple of tiny boo-boos there, it looks like. But for the most part, most people got it would be 3 over 3, I think, right? Okay, so we're pretty good there. Now, here's where it gets interesting. And you can see we've got a multitude of answers. And the correct answer is G. Now, that back table back there actually has the correct answer. Is it stopped? Well, it's not technically stopped for any longer than 1 instant of time, right? It's certainly not stopped for an interval. When is it actually stopped, Dana? At what times? 7 and 14, and I would even say at 0 too, right? Why is it stopped there? Because this is a graph of velocity.
Wait, what?
This is a graph of velocity. And when the velocity is 0, it is stopped.
Wait a minute. So those are the correct answers?
No, 0, 7, and 14. The correct answer is actually G, because it's never actually stopped for an interval of time. Little trick question there, but that's okay.
So you're saying it's not stopped for the entire.
It's not stopped at all for an interval. It's stopped for an instant, right? An instant. Okay, now, some of you might be wondering, why is it not stopped during interval B? What's happening in interval B right there? Still moving, constant velocity, because remember this is a velocity time graph. Okay? It is not a displacement time graph, so be very careful. I can't stress that enough. When is it moving backwards? Correct answer? Someone got it right? D, E, and F is the correct answer. D, E, and F. In fact, anytime the velocity is negative, it is moving backwards. Negative velocity means backwards. Which now will likely mean we've got similar kind of problems. Oh no, now slowing down. This is one of my favorite ones. I don't know. Correct answers are C and F.
I got one.
I'll give you a moment to look at that. C and F. How many people got the C part right? Yeah, how many people forgot the F? Probably lots of you, right? Why is F slowing down? Does anybody want to tell me? A great way to put it. It's going back to 0. That is exactly the way I describe it. The velocity is going back to 0. It's negative velocity, right? Right here, this is negative velocity, but the acceleration would be positive. And when the signs are opposite, things slow down. But I like the way Dana put it. When it goes back to 0, it's slowing down. Go ahead, Hannah.
May I retrieve an Advil from my locker?
Did it wander off there by itself?
Yeah.
Oh, all right. I guess if required.
Thank you.
So have a look at that. Does that make sense? Why it's slowing down there? Give me the nod. Yes, I get it now.
Yeah.
Yeah? Okay. What about when it's speeding up? Same idea. If we were to use Dana's words, we would say it's when the velocity line is moving away from zero. Like where? Like there and like there. The correct answers are A and D. Moving away from zero. The velocity must be getting larger numerically, either positive or negative. Nod. Yeah? Give me this if you don't get it. Because I need to know. A and D. When is the object moving at a constant speed? There is more than one answer. You should know it now. B and E. Lots of you got it right. Good for you guys. B and E. Either you're the smartest class ever, or I'm doing the best job ever of teaching this. Probably you're the smartest. Okay, here's where it gets even harder. Okay, let's talk now about displacement. Okay, so if you've sort of tuned out for a minute or so, it's time to tune back in. We're going to do one more round here on Jeopardy, and then I'm going to let you loose. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate over the time interval in question. Big fancy words. We're looking for the area between the graph and the time coordinate. The time coordinate is a fancy way of saying the x-axis, because what's on the x-axis? Time. Okay, so in the example, the displacement for the time interval A would be equal to the area of the triangle formed by the graph and the time coordinate. So if I'm looking for the displacement from a velocity time graph for interval A, which is from 0 to 2, I need to find, here's my graph, I need to find the area between the graph and the time coordinate. And in this case, it makes a triangle. And so we use our area of a triangle formula, which everyone remembers is half the base times the height, or if you prefer, base times height divided by 2. What is said base of triangle? From 0 to 2, 2. The height is from 0 to 4. So I got 1/2 of 2 times 4, which is 4 meters. The displacement for interval A is 4 meters. Even though the velocity is doing what? Going up from 0 to 4. Good? I won't go into a long explanation of why. It actually does involve some calculus there. Okay? Integrating really just means finding the area. When you take first year university and some crazy professor starts talking about the area under the curve and integration, you can think back to this day and you'll say, that's what Mr. Bennett was talking about. Just under the velocity time graph. And integration. He might even the professor might draw this kind of crazy symbol that looks sort of like a bit of an F like that. And then he would go like a 0 and 2 right there, and then they do some fancy mathematical stuff, and they get an area of a triangle. Okay, now what do you do if there's more than one time interval to be used in the calculation? Then the total displacement is simply the sum of the displacements of each time interval. In other words, add them together. If the displacement for the intervals A and B were to be calculated, the following technique would be used. We find the displacement of A plus the displacement of B. And displacement B is from 2 to 5. You'll notice that it's what shape? It's a rectangle. It's a rectangle. And this rectangle is from 2 to 5, which is 3. And from 0 to 4 is the height. So 3 times 4, I get 12. And I add it to my previous 4, you get 16. All right?
Are you going to give us all these formulas on the test?
Area of a triangle?
I was like,
There's this thing called a cheat sheet.
I'm not giving you any formulas, Jason. You can't remember base times height divided by 2. I recommend you write it on your cheat sheet. Now, what if the graph is below the time coordinate? Then the displacement is negative. The displacement for the time interval D would be calculated shown below. Now, D is this guy right here. Now, you will notice this is the most common mistake that I see over and over and over. When it's below, people want to do this, and they want to go right down to 0. And that is wrong. Why is that wrong? Because it says the displacement on the VT graph is determined by calculating the area between the graph and the time coordinate. Where is the time coordinate? Above. It's the 0. So really what I'm talking about is this area right here. In fact, the calculus professor would say the area above the curve, above the graph, above the line, above the function. Okay? Quite often they will say area under the curve. They are implicitly meaning if it's negative, then it's above. They don't come out and say it. They just mean it. Okay? But you need to know that it's above. Don't make that mistake. So that triangle there would be from 7 to 8.5. It would be 1.5. The height would be from 0 to -3. And so I would have 1/2 of 1.5 times -3 minus 2.25 meters. On a scale of 1 to 5, tell me how much you get it. Remembering the getting it. You see that? Got it? Did you see my new poster up there? Jake, read us that poster there for people that can't quite see it. It's kind of small.
Does get it mean getting an answer, or does it really mean understanding what's going on?
Okay, so is it? It's just up there by the clock, to the left of the clock.
Was it a scale of 1?
Yeah. So again, on a scale of 1 to 5, I need to know: do you get it? Do you get more than just get the answer? Do you get it? 1 to 5. 1, Jordan? 5 is I get it completely. Oh, okay. Talked into a 2, eh? So I got a couple 1s, a 3, a 4, a 2. Okay, I better. Well.
I know what to do. I just don't know why.
Oh, okay. Well, how about we do this? Find the displacement. Well, we'll do it the reverse way. I'll force you to make a mistake, and then I'll explain it. I'll get your attention by making you make a mistake. I want you to find the displacements for C, E, and F. C is this one, E is this one, F is that one.
How do we know when the actual time is?
It's from, we're going to assume it's 8.5. Yes. First one is from 5 to 7. Same ones before. How did we do? Well, interval C is a triangle with a base of 2 and a height of 4, giving us a area of 4. How many people divided by 2?
Wait, isn't it negative 1?
You're right, it is the same as the first one.
It's above.
It's above. Even though it doesn't matter that the velocity is doing this, it's above. Whether it's above or below.
Oh, I think I got all the answers right. I just picked up the English.
Okay? So interval E is clearly below. It's a rectangle. Correct answer is minus 7.5. Rectangle, minus 7.5. Well, it's from 8.5 to 11. So 11 minus 8.5 would be 2.5, isn't it?
Yeah. Can you just go 2.5 times 3?
That's what it is.
Okay.
And the height is 3. And it's actually technically the height is not 3, it's minus 3. That's how you get that negative 7.5.
How many times 3.5 to the
Because you get it quick enough thing. Interval F, minus 4.5. Okay. What about, I'm almost done. What about on a velocity time graph if you are asked to find average velocity? Average velocity. Whenever the average velocity is to be calculated under any circumstance, at any time, from a velocity time graph, it must be done using the formula v bar equals d over t, where the displacement is calculated from the VT graph using the area under the curve technique. In other words, you have to do the area first. You cannot, I repeat, you may not, should not, will not, whether it's in a boat with a goat, I don't care, don't do it. Don't ever do this. Do not go, 0 plus 4 plus 0 plus minus 3 and 0 and average them. Do not ever do that. Don't do that. You must find the displacement first. The average velocity for the time intervals A and B A and B, which are these two right there. How do we do it? You cannot just go 0 and 4, the average is 2. Doesn't work. What if it was 0 and then 1 and then, or sorry, 2 and then 4? But what if it was 4 for like, I don't know, a year? Clearly the average would not be 2. The average would be pretty much 4. Okay, so it depends on the time too. You can't just take the two numbers and add them together and divide by 2. So, how do I find average velocity? For intervals A and B, I have to find the area first. We know the area for A, we've already previously calculated it to be 4. We know the area for B, we've previously calculated it to be 12. Because it has 2 to 5 is 3, times 4 is 12. So it means my total displacement for A and B is 16, giving us an average velocity of 16 divided by 5. Why 5? It's 5 seconds. So in fact, the average velocity for this little bit here is 3.2. So it'd be somewhere like right around there. I would now like you to calculate the average velocity for the entire trip. Calculate the entire velocity of the entire trip. Now you've already got all the individual displacements, A and B and C and D and E and F. You may have got C, E, and F wrong, but you now have the correct answers. Find the average velocity for the entire trip. Let's see how you did. Correct answer is 0.4. Yay! Lots of people got it right. What are the numbers that you need to make that right? Well, we've got 4 and 12. We got 16. How much was C? We got 4, 12. How much is the displacement for C? It's 4. And then down here we've got negative. This is negative what? 7.5? 2.25? 7 to 8 is 1.5. And 3, 1.5 times 3 is 4.5, and half of that is minus 2.25, like you said. From 8.5 to 11 is 2.5 times 3 is minus 7.5. And then the next triangle is from 11 to 14, that's 3. The height is minus 3. That should be. And when you add those all up, how much do you get? 5 point what? 5.75? I'm going to trust you. You add them all up, and then you divide by how much time? 14 seconds. Okay? Make sure you know how to do that. If you don't get that, go back tonight, have a look at it, maybe tomorrow, look at it, figure it out. Watch the video again. Now, instantaneous velocity, nothing could be easier than instantaneous velocity, because remember, this is a graph of velocity. So instantaneous velocity, read it off the graph. So the instantaneous velocity at 6 is equal to 2. So what is the instantaneous velocity at 13? You do not need a calculator for this. You read it off the graph. At 13 seconds, the answer is minus 1, is it not? You read it off the graph. It is a graph of velocities. Okay, last one, I promise. Instantaneous acceleration. I can tell that you're wearing, my instructional time is wearing thin. Instantaneous acceleration. Instantaneous acceleration is determined the same way off VT graphs that VINS was determined off PT graphs. That is, find the slope of the VT graph. We are looking for instantaneous acceleration. You must find slope. If it's instantaneous, it's a tangent, but only a tangent if the line is curved. If it's straight, well then it's just the slope of the line. So in other words, the instantaneous acceleration at 6 seconds, which is right there, we're talking about acceleration, so we're talking about the slope. What's the slope of the line at that point? What's the slope of the line over the entire interval? So it's 0 minus 4 all over 7 minus 5, and you get an instantaneous acceleration, a slope of minus 2. I ask you this, does that minus 2 mean that the object is slowing down? Peyton shaking your head both left and right and up and down at the same time. It's like a bobblehead. Does it mean slowing down?
Yes.
In this case, it does. In this case, it does. When might it not indicate slowing down? Well, like right there, it would be minus 2, right? Hannah, this is the part that's important, not the dancing part. Here, the slope is still what? Minus 2, but in fact, it's actually speeding up. How come? Velocity is negative. It's moving away from 0. It's speeding up negatively. Yes, it does hurt your brain. I don't dispute that at all, Jim. Please find the instantaneous acceleration at 12 seconds, and then I will leave you alone. Correct answer is 1. You are finding the slope.
Character back.
I said positive, he said negative.
Let's have a quick look. We got a couple minutes left here. We are looking for the slope. Clearly the slope is what?
Going up.
Going up. It's positive. What's this endpoint right here? It's going to be 0 minus 3 all over 14 minus 11, which is 3 over 3 or 1.
Where did you get the 3?
Where did I get the 3 from? It goes from, that's minus 3 right there, is it not? So it's this point here, Ryan. 0 minus 3 all over 14 minus 11. Okay, last thing I'm going to say, this sheet right here, you guys, you can start on the hand-in on the weekend, you know, if you're looking for something to do, that kind of thing. On Monday, I will go over the most important 2 sheets that you will own ever in your life. Well, I may be exaggerating a little bit. I will go over these next 2 pages, extremely important. Have a great long weekend. Don't forget there's no school tomorrow.